All right, welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly. I'm your host, Joel Moses. Alongside me, as always, my co-host, colleagues, and friends in all things WebAssembly, Oscar Spencer and Matt Yabuchi. Welcome, guys. As always, we are here to provide a viewed from on-orbit perspective of what proposals, changes, and updates mean to the Wasm standards and generally blast off hot rays of marginally entertaining sunshine in your general direction. I'm super excited about our Wasm community guest today, and it's a bit of a change from our normal focus. More about that in a minute, but lots been going on. Let me introduce my compadres, Oscar and Matt. Welcome, guys.
Hey, everybody.
What's been going on?
Oh, man. So we're just off the heels of WasmCon, and oh boy, was it an absolute blast to be there in Salt Lake City. Now, it's been amazing to see Wasm grow over the years. I think next year Wasm's going to be 10 years old, which is kind of insane to think.
Wow.
But just seeing day one of WasmCon and seeing an absolutely packed room for the keynotes was truly amazing. I gotta say, there was maybe 400 or 500 people and people standing in the back, which was absolutely amazing to see how many people care about WebAssembly, how it's really catching on. So that's super duper exciting.
That's great. Do we have numbers of how the conference has grown?
I'm not sure. I'm sure I can ask some folks, and I'm sure we can get some pretty solid numbers.
I know there were some people who were skeptical about combining it with KubeCon, but I think it actually boosts the attendance numbers significantly.
Yeah, absolutely. And I'd say probably the most exciting thing for me coming out of this is that, hey, WASI Preview 3 is slated for the first half of 2025. And a lot of people are wondering, is it going to happen? I surely hope so. I'd be truly excited. But folks are jazzed up right now, and I think we're going to see a lot of momentum.
That's great. That'd be a nice Christmas present, wouldn't it?
Oh, absolutely.
Yeah, that's super. Could you give us a couple high points on what that's going to include?
Yeah, WASI Preview 3, the big two things, async and streams. Two very, very important things. But namely, if you look at WASI Preview 2, we've got WASI IO, which is an interface that just handles any kind of input and output, and it shows up in every other interface. So when you see something like that, that's always a smell that says, hey, we need to do something about this. So we need to have a way to say, hey, how do we stream data in and out? And even more exciting about the stream type, it's a stream of T. So you can stream whatever data structure you like. It doesn't have to just be bytes or something like that. So I think we're going to have some really awesome, clean interfaces, and it's going to be amazing to see how it shows up in all the different programming languages. So super exciting stuff. It's going to be
very cool.
Good time.
Very cool. All right, we're going to reverse course a little bit. I know we talk a lot about WASI here. Of course, that glosses over the fact that WebAssembly has been around on the client side for a very long time and has been doing some really important work there. So I'm going to take the podcast in a slightly different direction. We're going to go in the client direction, and we're going to go backwards a little bit. We're going to go backwards to the halcyon days of the early World Wide Web. I got a pop quiz for both of you. How many websites were online at the end of 1994? Do you know? Take a guess.
24,000.
I'm going to say 100 grand.
You're both completely wrong. The answer was not quite 3,000 sites.
No shot.
3,000.
No way. Really?
Wow. 3,000 in 1994. Now, cast forward to the dot-com crash around the year 2000, and how many websites were there then? Do you know?
Millions.
Yeah, there were millions.
10 million-ish.
It's about 17 million websites. Okay. Now the dot-com crash happened, and of course that doesn't have anything to do with the number of websites. It's about the irrational exuberance of investors in dot-com properties. But only 7% of the population of the planet even had internet access in the year 2000. So 17 million, 7%. Now let's compare that to today. There are, by some accounts, 1.88 billion websites online. And in most of the world, over 97% of citizens have internet access. So the amount of information being generated and stored on the web is massive. But what about that early content? Now, during the dot-com crash, for the very first time, large bodies of information, entertainment, and research went offline. And for some of them, it went offline permanently. So folks like the Internet Archive, which was formed in 1996, were left to try to do for the world what government entities like the Library of Congress traditionally did, create a more permanent record of the information. But what happens if the media that was generated not only isn't readable anymore, what happens if the technology that it's grounded in is abandoned and possibly dangerous? Tabitha, let's bring up the first kit here. How many of you, when you look at this, automatically hear something in your brain? And what do you hear? Badger, 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 mushroom, mushroom. This
For me,
is
it's a snake, a snake.
snake,
Yeah,
snake,
yeah.
snake.
You're
Right.
you're bringing you're bringing back memories here. Yeah.
Absolutely. So this is like one of the earliest forms of very short hit, quick entertainment. It's I like to kind of think of this as kind of the proto meme, right? Before memes were a thing, this was a thing. And yeah, it's a trifle. It's a tiny piece of entertaining thing. And then there was something else. Let's go forward one, Tabitha. How many of you know who this is? This is Homestar Runner, right?
Yeah, no, Matt and I definitely know what this is.
Oh,
Yeah.
absolutely,
Yeah, yeah, yeah,
absolutely.
yeah.
Homestar Runner, an incredibly interesting web property from the early days, but entirely grounded, just like Badger, 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 in a single piece of technology, and that technology was Adobe Flash. Adobe Flash, it's not just for small properties either. The websites for the first Harry Potter movies, a lot of people forget about that. Shrek, Charlie and the Chocolate Factory, all done in Adobe Flash. And Adobe Flash has largely been discontinued and in some cases removed forcibly from browser clients because it's quite simply dangerous. I'm not going to blame Adobe for that. Adobe saw the early days of the web were kind of gray and boring and lacked things like animation. So they were early to the game at implementing and giving designers what they needed in terms of interactive features. But remember, this is in the early days when we were still talking about multimedia being on CD-ROMs. So I can't blame them for advancing the technology perhaps more rapidly than security controls on the technology. We have all this early entertainment that's on the web, and now it's in a state where it's barely readable at all, or it's not executable at all because the grounding technology has disappeared. So there's a whole bunch of people in the world of WebAssembly that decided to take that on as a task, and it's time to introduce our guest. If you could bring him on, Alessandro Pignotti, founder and CTO of Leaning Technologies, the makers of the Chirp products, which we're going to find out a bit more in a minute. And in the early days, the creator of Lightspark, one of the earliest open source projects to tackle Adobe Flash compatibility. Alessandro, welcome.
Thanks a lot. Thanks a lot for the introduction and for having me here. I'm very excited to go back a little bit to what I used to do when I was a much younger student.
So what was it in the early days that helped you decide to create Lightspark? Was it a specific piece of entertainment? Was it an application that you needed to make run again?
You know, it was, as often happens, it was the need to scratch your own itch, right? And I remember that back in the days, the right solution to run Flash, if you really wanted to stick to open source tools, it was to use the Gnesh tool, which was supposedly part of the GNU project, but it was effectively abandoned for a very long time already. There was no hope inside that would have ever supported the modern Flash, well, modern at the time, of course, contemporary maybe should be the right terminology here. Version of the Flash language, which was called ActionScript 3. So Ganesh supported up to version 2, but ActionScript 3 was a completely different beast. It was actually an implementation of ECMAScript with extensions. It was quite sophisticated, and it was also it also supported a gigantic standard library that was effectively used then from the artist perspective to do the animations and games and all these sorts of things. So it went really in depth. For example, it will be much larger than what is now, for example, Canvas, right? Canvas in HTML5 lets you draw geometries, and you add that plus much more.
Yeah. But of course, it's really difficult to re-platform things, right? So if you have an earlier piece of animation that's done, re-platforming it into Canvas is not exactly the easiest thing in the world, is it?
No, not at all. And because, of course, there is not only that, right? And then there is additional level of complexity that Adobe Flash is actually very poorly specified. So there is ample documentation of what things are supposed to do, but the level of documentation is something along the lines of this API draws a line, but there is a lot of detail in how you draw a line, right?
Right. Uh, so a lot of the early days of the web is tied up in some of these objects that it's not just necessarily Flash. It's also Macromedia Director. It's Java applets that form functional parts of certain applications. A lot of administrative controls or administrative interfaces in network appliances of the day were written in Java. So a lot of the early days of the web, we kind of have a hangover from, don't we?
It's we have this sort of leftover of fossils maybe that are still used by a surprising amount of people. So one of the tools we work on it's ChipJ, so it's a JVM, WebAssembly JVM that can run any Java application in the browser. And one of the small use cases for this is running legacy Java applets. And believe it or not, our free Chrome extension to solve this problem, it is used by north of 100,000 people still
Wow.
actually using
Wow.
applets. It's incredible, right? I would never have guessed.
Well, we actually have the co-creator and maintainer of the Java language specification who works with us, and he has regrets to how the landscape of Java applets grew over time. Uh, that's putting it mildly, isn't it, Oscar?
Yes, it is.
Uh, but again, legacy things are still usable, right? And a lot of people don't necessarily have the time or wherewithal to re-platform or retool, especially if they didn't create the Java applet in the first place and they're simply a consumer of it. So, talk to me about how you go about uh, making old stuff run anew. What exactly with WebAssembly makes it the right choice to engineer something like this?
Well, to a large extent, yeah, I think you really struck the right point when saying that a naive view will be you just can re-implement stuff. Why don't you just rewrite everything in JavaScript and HTML5? And the thing is that you can, of course, do that, but it takes resources, right? And not everybody has the resources to do so. And what we have noticed over the years, supporting the extension specifically, is that it's used a lot by the educational community, especially in underserved communities and countries.
I
So
can
you realize
totally
that there
imagine.
is really a wealth gap where people which are wealthy enough they can access content made anew for the new platform at the moment, while people elsewhere get left behind.
Right.
So although this was not truly the original purpose for the extension, it was from our perspective mostly a demonstration of the technology and a way to convert into sales. It was actually we discovered it was really useful for lots of people which had a deep need of using these tools. And fundamentally what the role of WebAssembly in all of this is to uh, you know a side note here. I would say the role of WebAssembly here is that it allows you to run arbitrary complex code in the web platform, right? Which is a way of looking at the problem, but it's not necessarily the actual truth. So WebAssembly can make things run somewhat faster than making things purely in JavaScript. But from the capabilities point of view, there is effectively no difference whatsoever. So, when I try to explain WebAssembly to either people joining the company or students here in Amsterdam, when I get the opportunity of doing a talk or something like that, I always say that WebAssembly by itself cannot do anything at all. It's just if you have no imports, that's a technical term that you guys know. But if you have no imports, you have a sandbox that can run a for loop and then do nothing with the result. So it's not very useful for anything, right? So all the actual capabilities to interact with the user and the platform and the rest of the web comes from JavaScript effectively, which means that really everything you can do in WebAssembly, you can do it in JavaScript. In WebAssembly, you can do it a little bit faster. But what we have discovered is that as a company, it is very difficult to convince people that our tools are legit if we don't say that we are WebAssembly based, and we are. It's not that there is no trick here. We are WebAssembly based, but there is lots of JavaScript involved in many things. But as a simplification, we say we do WebAssembly things because it makes it easier for people to conceptualize that some things are
Right.
possible.
Mhm. And so, how have you found sort of like actually putting this together to get users to actually use it? Like, how has the reception truly been?
I think across all our products, really, the reception has been really great, but it got great over time. I remember at the beginning when we first released ChirpJ, I remember this beautiful Reddit comment this guy said, on a technology that was released with demos that were available. This guy commented, "Yeah, this is clearly impossible. This must be fraud." And they could literally go and visit the demo. So it was quite absurd for me to work around this. But Reddit is Reddit. You
Yeah.
cannot do much about it.
Mm.
But in more recent days, I think that the user population has sort of adapted to the idea that some things are possible. And when we recently released the WebVM 0.0 demo, which allows you to run a complete desktop environment in the browser, people accepted it as something, some users even as something obvious, right? Because now there is this
Yeah.
funny idea that, WebAssembly is assembly. So you of course can run binaries. It's obvious. And although there is still quite a bit of distance there.
Yeah, absolutely.
And so, one other question you had mentioned, sort of WebAssembly can run things maybe a little bit faster. So, for something like Flash, have you had any issues, like technical challenges with like timing of things that depend on like? Because I know a lot of old internet content might assume your processor runs at a certain speed or something like that. Have you run into any kind of issues like that?
So Flash, I think from this perspective was relatively modern because it was really oriented around trying to achieve a specific FPS.
Mhm.
And actually now I recall that they had a pretty sophisticated model that was achieved since they had this idea. I remember the terminology here. It was called the elastic band or something like that, where the amount of
Right.
computational time you had during the frame was sort of scaled depending on how much you was taking, since you really wanted to hit that animation frame rate, and animation was the main driver of the whole thing. So other things could be rescheduled around. So it was quite modern in that regard. But this does happen when trying to emulate DOS, for example. When working on DOS games, you do have the issues that things spin out of control way much faster than the original machines ever could.
Totally makes sense.
So you mentioned, so I hope we have a chance to talk a little bit more about WebVM, but you mentioned something that really caught my attention just now. We've had people on the show before talking about needing to almost fight for WebAssembly, or like it's a tough choice to make because it's a new technology. You're saying the technology choice is driving trust. Like that's fascinating to me because it reverses the decision, or the reverses the like the paradigm. What kind of risks are you mitigating, or in with the new technology that's moving really fast, does that cause problems for you?
So to a large extent, we try to really ride the wave, right? We are part of the standardization process. We contribute our own ideas, and we help bring some of this idea to the final stage. We have directly impacted, for example, on the evolution of return calls that were stuck for a long time, and we have unblocked them just by sheer will. And we also standardize branch chains, so which is something that is completely made in Lean technologies. We did it all ourselves. And so we are always at the forefront, but we do see that there is a little bit of misconceptions, but the misconception as well often about security when it comes to WebAssembly. But this misconception also often come from a subset of the user population which is sufficiently knowledgeable to realize that problems could exist. When looking, for example, when we try to pitch and sell our products to enterprises, usually that is not the concerns that we see, because in the end, the people have problems, which are real problems, that like we want to access this legacy application in the browser. We can show them a solution that is a one-click solution. It just works. They're happy with that. The concerns sort of go into second hands. We do have sometimes tricky discussions with CIOs and the like that ask questions about the security of our tools, not realizing that some of their concerns just cannot apply. So we had recently some troubles explaining our technology to some actually regulatory body, since they somehow, I don't know what they saw, but they said something along the lines of, we noticed that your tools open a port to the internet, which is impossible. You just cannot do that in a browser. There is no API to open a port to somebody else. It cannot be done. But it was difficult to explain to a regulatory body that guys, what you're saying just is not possible. I don't know what you saw, but it was not us. It was something else.
That's interesting. So, obviously, you've had your products in market for some time now. Can you describe for me? And you don't have to give me any customer names or anything like that. But is there a particular use of your product that you saw a customer using it for that you were really impressed by? That you were like, yeah, that's why we made that.
So
What was it?
I will not make names, of course, but one of the projects that I think that, really show what is the importance of legacy, which I can see it as a little bit of a negative connotation, but legacy also mean that it's things that work and people have spent decades building, right? So it's one could also call them structural software if you don't want to use the word legacy, things which are really important for businesses to run. One of the things we worked on was an internal configurator. If you're not aware of this term, what a configurator is what big companies use to allow salesmen to partially automate the sales process of very complex product that involve many different parts, many different options, many different maybe consumables along the way, and not all combinations of possible discounts and parts and options can go together. But the sales people do not know the technical details, so there is software in the middle of how to make this part of the process. And one of these tools we worked on was originally written in C++ with the MFC framework, which was an ancient thing. I remember it was shipped as part of Visual Studio 6.0, which was my first compiler when I was a kid.
That's legacy, all right.
That is certainly legacy in terms of frameworks. It looks horrible, but we managed to do a project where we took all the business logic, which is also the valuable part. We've compiled it, and we have attached a newly designed purely web modern interface on top of this. And for this product, you may not believe it, but the total amount of sales per year running through this product was in the order of the billions.
Wow.
So for this company, a slight mistake in their implementation of this tool could have caused significant losses. So in this case, you really cannot risk it. They were stuck with the code that they had because they know this code works, and with this code we managed to make billions per year. We don't want to make mistakes over here.
Yeah, WebAssembly in the middle of it too. Yeah, I like what you say about legacy. I agree. Legacy has a negative connotation, but Oscar and I work for F5, and of course we're in the middle of legacy application sets all the time. And what defines them is the fact that they still hold significant value. The companies have built over time a set of really complex bits of logic, and they've come to trust and rely on that, and they make a lot of money from it. And that's the reason for legacy applications to even exist still. Now, it's really difficult and risky to go back and re-implement or re-engineer them, and so you're sidestepping
downright
that
impossible.
slightly. Yeah, it may even be impossible, especially if the tools are no longer available. But with WebAssembly, you can kind of sidestep that a little bit, which I think is pretty fascinating. I want to give you time to talk about some of the products in the line, and I want to understand the growth over time. So you started with Chirp, which is the compiler, right?
Correct. Yes.
About when was that released?
Pretty much at the very beginning of the history of the company. So we're talking about 2013. We're talking effectively the same timeline of WebAssembly itself. So Lean Technologies has existed for about as long as WebAssembly as a technology.
Early adopters, so to speak.
Indeed.
Now, from there, what was first? Was it Chirp J or?
It was Chirp J, yes.
Okay.
So we first expanded to Java, and we are a small company. So the way we managed to have so many different things built by such a small team is that there is lots of synergies in our product. So Chirp J is built with Chirp. Chirp J is written in C++, and is compiled to JavaScript and WebAssembly. So we take advantage of the power of our tools to build more advanced tools.
Got it. And was Java the next most obvious thing, or?
It was not necessarily obvious, but it felt to us that there was room. So I started studying the problem. I managed to quickly prototype something that seems to work. There were some mistakes along the line. So myself, I'm not a Java person, so I sort of figured out. I learned the JVM before I learned Java the language, which may be a little bit absurd. And the original version of ChirpJ was based on a ahead of time compiler, which was very effective because it allowed us to recycle effectively all the compiler infrastructure we had written for C++. We generated LVM and then we compile LVM to JavaScript using our existing compiler. So in terms of the pipeline, it was very efficient, and also effective in a sense. It was both very optimized, but also easy for us to write because we did not have to write a new compiler from scratch. Then actually in recent times, we released last year, we released ChirpJ 3.0 with a completely new architecture that's actually completely a just-in-time compiler, where we generate all the code just in time in the browser, because it turns out that Java really wants to be just-in-time compiled.
Mm-hmm.
Yeah, definitely so. Now, what else is in the chirp line?
We have ChirpX. So ChirpX is the new kid on the block, the last product. And as one of my employees said, fathers are not supposed to have a favorite child, but ChirpX is my favorite child. It is in a sense really the culmination of years of work and of building of the company and the tools. Since I had this idea of being able to run arbitrary binaries in the browser with a big focus on games, on legacy games, and it took me a while to get there, but in the end we could. Doing games is actually the next immediate step. We are now done the desktop. Next thing is going to be Wine, running Windows games in the browser.
Oh, wow.
Okay.
That's pretty wild. Now,
A WebAssembly Steam Deck, right?
Yeah. What's the motivation behind? Was it games? Was it games that motivated you to do that primarily, or what?
I think that in terms of, if you want to, there is a little bit of the spirit of remembering how I was as a younger person, right? So as a kid there, I remember the excitement of running the games from that age, because effectively those will be the first target, because they're the one that better aligned with a technology that is still maturing, where I know that over time I will be able to get to more modern and more intensive payloads. But of course, starting from the early stages of Windows game, it's easier from the performance standpoint, right? So it gets me a little bit back in the days. But even just looking at the commercial side of things, companies spend a ridiculous amount of money and computation on server-side virtualization.
Mm-hmm.
So the running of legacy binary application on the server side and then streaming the results to client is extremely common in the enterprise sector, and that's a business where we want to get a share of that. So this is where we are going. But the nice thing here is that we do plan to have the gaming version of this for free, available as an extension. This
That's
is part.
nice. I'm gonna have to take advantage of that too. I have some early games I'd love to execute too. It's interesting, and it kind of calls back to our original conversation. Looking at the Internet Archive at one point, they looked into the state of early web games that existed prior to the year 2000, kind of moving out into the year 2000, and realized that of the top 100 games of the time, over half of them are lost to history. Primarily because they were either completely web based and the property went out of business and didn't transfer the code, or didn't have any way of archiving it, or it was a Flash game. I think a lot of us forget how popular Flash was for delivery of games back in the day, and of course a lot of early gaming culture came out of the games that were massively multiplayer or web delivered in the early days. So it's definitely something to think about. Now,
and Archive, I had some experience with Archive because it is quite common that people access applets on Archive because they are not available anymore on the original property, right? And it's quite sad that Archive did a tremendous job in trying to save as much as they could, but the reality is that lots of resources were only implicitly referenced by the page. So if you had applets where the list of resources was all available in the tag, Then it was possible for archive to get all the data, and it's
Right.
still possible to use them via our extension. But it was often the case that the applet would just reference a directory on the web browser, and Java would dynamically load classes from there. And in this case, this stuff it's lost. It's just gone.
Yeah, I think it's worth pointing out also that our friends at the Internet Archive are also struggling with things like cyber attacks. I believe in November, they had a critical cyber attack that took a lot of systems offline and actually damaged a lot of systems, which is terrible. That's like defacing a library, in my opinion. But maybe that's just me.
Burning Alexandria, right? Yeah.
I also want to point out that Internet Archive is also a nonprofit, and as such, they could use any support that anybody is willing to give them, and they're doing wonderful work. There are plenty of times I don't know how many people periodically need to go back and sample something from the Wayback Machine, but it's a huge resource that is incredibly valuable. And if you haven't, please go check them out and go contribute, go support them.
Yeah, absolutely. And Alessandro, you had mentioned a while back about maybe potentially using Wasm GC in the future. I'm curious, sort of as your work on all these projects continues, what are you most looking forward to in terms of the WebAssembly specification evolving over time? What would help you the most?
Well, that's a very interesting question. I have my eyes on memory mapping. So the ability of controlling the address space would allow us to, especially for the for Chirpex, so for x86 virtualization, I think it will be the single thing that would probably allow us to maybe slash the slowdown by half. Just that by itself, we had to do some quite crazy tricks to get to the state where we are right now on memory virtualization, on a completely software-based memory virtualization, which I suspect we actually invented a few new things along the way. I'm not sure, but I think so. But having the ability of actually controlling data space would be absolutely phenomenal. I know there is discussion in that direction. It also seems to be a very contentious topic. So
Yeah, it is.
I am not sure what will happen there.
Yeah, no, I mean the main. I think people in general want it. People just are wondering how are we going to implement this from a security perspective. And as soon as we figure that out, I think it's totally going to happen. So I think it's. I think.
Oscar, can I ask you something actually, Scott, related to this? I was wondering if you could, if you had an idea of how, if there is any solution on the table to remove the performance overhead in WebAssembly 64-bit. Because this is something that I don't have clarity, because it is clear to me how it works when you want to sandbox a 32-bit address space in a 64-bit address space. You have a large mapping around it, you guard everything, you disallow every access, and you're done. But on 64-bit, where potentially any pointer is valid, how can you actually avoid the checks on the memory length for every single memory access? What's the plan there?
Yeah, I'm not an expert, but I asked Alex Crichton this exact question, and I think the answer he gave me was there's a bunch of clever tricks that you can do for the fact that you're not going to use the entire address space. So I think that you actually have a bunch of padding that you can use to do a bunch of the bounds checks because no, you're not actually going to use however many petabytes of memory you have access to. And so there's a bunch of padding in there that you can use to do some of the bounds checking and get a bunch of the performance back. And I think there's some other tricks you can handle there. I just think people haven't optimized it too much yet. But I'd be skeptical of it getting to the same level of performance as Wasm 32 without custom hardware.
Now on that end, there are some research projects going on between some Silicon partners and the WebAssembly community about adding specific processor opcodes to allow things like this to occur without a significant penalty. So some of the research going on there is looking pretty promising as well.
Yeah, so I think it will get there, but I think it is going to take a little bit of time.
Yeah, definitely. I want to leave a little bit of time here, Alessandro, to talk about the latest release that you guys have, WebVM. If you want to give us the rundown on that one.
Yeah, so I think that the story of how this evolved since our first demos, I think it's quite interesting in itself, because the first demo we released, I think around 2 or 2.5 years ago, it was a Python repo. So you will get inside the web page. I think the URL was python.reintech.com or something on those lines. You will get into a Python interpreter. You can run whatever you want. So based on running the Python binary inside the browser. But Python is also something that's been done in many different ways. our specific implementation was based on running the x86 binary. And the cool thing about this idea is that we then had sister pages for Ruby and for Node.js, and it was exactly the same. So it would just run any binary you wanted, right? And we had that. It was the first thing we did. And then we sort of moved forward and said, okay, let's do another demo where the executable you run is bash. So we do bash.int.com. We do the same thing for bash. Then I remember the engineer that was working on this bringing to me the demo. I tried out and I say, okay, but this is much more, because I didn't realize before, but when you have bash, when you are inside the terminal, you don't type just bash. You have a system. You have a VM.
Sure. Yeah.
Then I quickly went on a registrar and tried webvm.io. Register not, I get it. So WebVM was born out of this sudden realization that we had on our end something much more powerful than we even realized before looking at it. But when we looked at it, we clearly fell in love with the idea, because it was clearly something amazing. And so the first version we released was the terminal-based one, and then recently we released a new one which allows you to interact with a complete desktop. So, and we run the complete Xorg. So there is Xorg running in the browser that can display content over a canvas by implementing the KMS API.
Oh wow.
It's quite a journey.
Yeah.
Yeah, I mentioned this at the very start, but we spend a lot of our time doing focusing on WebAssembly on the server side, and a lot of times I forget how much work and how much inspiring stuff is going on in the client side of things, and it's always great to get a good reminder.
So it sounds like, if I understand correctly, it sounds like WebVM started coming from an experiment, or coming from a what's possible, like an aspirational goal. What kind of things do you see people using it for, and how capable is it? Right, like we have WebAssembly in the browser, that's sandbox. Do we have device access? Do we have socket access? Things like that. It's fascinating to me. Absolutely fascinating.
So what you can do in terms of capabilities depends on the specific thing we're talking about. So the general approach is that everything is virtualized. In one way or another, that's how you solve problems, right? This is also one of my usual things I say to new engineers joining the company when somebody comes to me and says, well, yeah, we cannot do this in the browser. And I say, you can do everything. It's just a matter of virtualizing it in the right way. In the case of files, there is a virtual file system with multiple backends. The share of the lion here is taken by X2. We effectively run a complete X2 file system on top of a block device, which contains the whole file system. Effectively, that's the only way at scale when dealing with very large file systems. We could also get every single file via HTTP. It just does not work at this scale. It's you need block-based device for that. Networking, we solved it in a very interesting way, I think, by integrating with Tailscale. So
okay.
So Tailscale, they had this, and they didn't know about that, but they effectively allowed connection from any browser tab and allowed people to effectively mesh with a VPN from the browser tab. And the reason for this is that they had something called DERP, which are these sort of proxies that take WebSocket in and connect with the rest of the Tailscale network. And the original reason they deployed it was for very constrained networking environments, right? That block anything that is not HTTP. And turns out that by surprise, the browser is a very constrained networking environment.
Yes.
But they were not aware.
Yeah, I mean, I was thinking about this and I was like, I mean, I guess you could use a WebSocket and try and send everything over that, but it would suck to build that, but then someone else did. So that's awesome.
Yeah.
So it's not about building it, which is not the best use of our time. Is management of data. So with Tailscale, what is great is that the user itself will set up the exit node for his data. So he will be ultimately responsible for it. We really don't want to be responsible for arbitrary traffic from our
Oh, yeah.
Yeah. Now, Alessandro, you recently just had a hackathon, if I remember correctly, for WebVM. Is that correct?
Yes, that's correct. And, it was in Leeds, where we have one of the headquarters of the company. So it was strongly tied with the students community there, and it was the first time we actually did an event like that, and it was really lovely. It was a way to expose some young people to the power of WebAssembly, and we are planning to do another one probably in the spring. So I will actually invite the listeners to follow us on social media at Leaning Tech on X, since they will be able to find our announcements there about the upcoming hackathon.
With that, we are fast running out of time, and I'm afraid that's the time we have for today. I want to thank you, Alessandro. As I figured, it was going to be a great discussion, and it was. Talking about the early days of the web is always fun. Badger. And congratulations on your latest releases. Again, thank you so much.
Thank you,
Yeah,
guys.
thanks.
It was
Thank
a
you.
pleasure being here.
Great. And as
Absolutely
always,
amazing having you.
Yeah. As always, thank you, Oscar and Matt. It's a big application world out there. It's time to unleash the power and promise of WebAssembly. So for Joel, Matt, Oscar, Alessandro, and myself, thank you for listening in. Be sure to subscribe for future WebAssembly news and views.